Our star formed about 9.1 billion years after the Big Bang, or about 4.6 billion years ago. Formed in a mostly hydrogen nebula, the Sun with its solar wind cleared the nebula and settled into its galactic position. Some heavy elements that were in the Sun's gravity field did not fall into it. Instead, this material accreted into planetary masses. Our planet coalesced from a relatively cold dust of mostly iron, nickel, silicon, calcium, magnesium, oxygen, and other elements. When the planetary mass pressed together, the compression generated heat that melted the material and it settled into strata: inner core, outer core, lower and upper mantle, the crust, and the atmosphere. The crust cooled to rock about 3.8 billion years ago, and about 300 million years later, single-celled organisms appeared where surface water was present. There are three prevailing theories as to how the water got here, and they could all be true. The original water that accreted with the planet evaporated and remained suspended in the atmosphere until the crust cooled. The water arrived after the crust cooled in the form of comet showers, and that the decay of radioactive material by proton ejection and other free protons combined with the abundant oxygen atoms to create water. Early life also combined elements such as hydrogen sulfide and carbon dioxide to produce sugar, water, and sulfur. About a billion years after first life, or about 2.5 billion years ago, enough water accumulated on top of the crust that the pooling put pressure on the crust and it started to crack, and the continental plates started to form. Major abundance of single-celled organisms was present by about 2 billion years ago, and the first multi-celled eukaryotes appeared about 1.8 billion years ago. About 1 billion years ago, there was so much photosynthetic activity that the concentration of oxygen in the lower atmosphere rose to the point that it tipped the evolutionary balance, and there was a sharp decline in single-celled organism colonies and a sharp rise in multi-celled eukaryotes. The growing continental mass first coalesced at the equator around 530 million years ago and gave rise to an abundance of soft marine eukaryotes. Within the next 30 million years, the continental mass shifted toward the South Pole, mostly submerged. Here, there was another significant rise in eukaryote population and complexity, including the first land plants. Then, about 50 million years later, the continental mass settled on the South Pole and massive glacial ice accumulated, lowering sea level, and the second massive die-off occurs, including 3/5 of all marine invertebrates and about 1/4 of all life. About 30 million years later, or about 420 million years ago, there were massive glacial melts, substantially raising sea level and giving rise to the first salt and freshwater fish, land critters, vascular plants, and corals. Within the next 80 million years, or about 350 million years ago, the continental mass split, and what will become the North America, Europe continent drifts to the equator, mostly submerged, and major evolutionary advances occur, including first trees, first seed-bearing plants, first land vertebrates, and wingless insects. Within the next 50 million years, about 300 million years ago, the Siberian continental plate collided with the Europe-North American continent, and then a second collision with the South American African-Arabian continent. Now there was also a great increase in life, including the first large forests, the first land eggs. This is when the first coal deposits occurred. Over the next 50 million years, the continental mass coalesced in a continuous mass from the North to South Pole, and then the third massive die-off occurs and is most massive among ocean life. Then the first large seed-bearing forests occur, and then about 40 million years later, the fourth and even more massive die-off occurs, after which the conifers and the dinosaurs rise. By about 145 million years ago, the single continent starts to break up, and there is the most biomass, including the first flying dinosaurs and birds. At this point, the oil fields begin to form. About 80 million years later, or about 65 million years ago, the Earth is struck by an asteroid, and the dinosaurs along with much of life goes extinct, and gives rise to the first flowering plants, many of today's birds and insects, and the mammals begin to rise. By about 40 million years ago, most modern mammals appear and grasses begin to appear. About 10 million years ago, there was a major climate change when the African and Arabian plates joined the Asian continent, and Antarctica is isolated in the South Pole. The Antarctic continent collected significant ice, and there was a significant cooling and drying event. A circumpolar current was established, and ocean water mixing was reduced significantly, and kelp forests and grasslands first appear. About 4.4 million years ago, the first hominids appear. At about 3 million years ago, there was another major cooling event accompanied by significant polar ice and drying of the land. The Stone Age begins around 2.5 million years ago, with a stone axe being common around 1.3 million years ago. About 1 million years ago, a major warming period began. Many large mammals went extinct. About 500,000 years later, hominid use of fire begins. First anatomically modern humans appear about 150,000 years ago and have spread throughout all the continents except the Americas and Antarctica by 40,000 years ago. The Neanderthals first appeared about 120,000 years ago and disappeared around 28,000 years ago. The coldest phase of the last ice age began around 27,000 years ago, and it peaked at about 20,000 years ago, and then started a warming period about 16,000 years ago. At about 14,000 years ago, intensive harvest of cereals by humans begins. At about 13,000 years ago, the megafauna, including mammoths and woolly rhinos, went extinct in Eurasia and would go extinct in the Americas around 10,000 years ago, accompanied by a significant retreat of the ice sheet in Eurasia and North America. This retreat of the ice sheet continues today.